So thank you so much to everyone who is still with us. I think you'll agree it's been an amazing day one for the ESMAR conference. I'm personally really excited about this session on user interfaces, and we have some amazing speakers for you. Please continue to post questions for them in the Slack channel under the hashtag questions for presenters channel. And we'll either get to those at the end of all the 3 presentations here, or the speakers will get to them after the event, and everybody can access those at a later time. So without further ado, we're going to jump straight in with speaker 1, who is Clareece Nevill. Clareece has been working at the University of Leicester as part of the Complex Review Support Unit since April last year. And since joining, a lot of her time has been spent on developing the Shiny apps that the CRSU currently host for evidence synthesis. So over to you, Clareece.
Thank you. Cool. So hiya, good evening and thanks for having me. So I'm Clareece Nevill, and today I'll be talking about a pilot for an interactive living network meta-analysis web application that we developed last year. And I just want to quickly mention that this was very much a collaborative project, and to thank the other members of the CRSU that worked on this. So to 2020 and the delights of COVID-19. So trials for COVID-19 started being published back in April 2020, and there are now 2,533 clinical trials registered worldwide. And within these trials, various treatments are being tested simultaneously. These include pharmacological therapies such as hydroxychloroquine and remdesivir, and biological therapies, to name just a few. So as a consequence, an increasing number of protocols for synthesizing COVID-19 evidence have been registered worldwide. Currently, there are 489 systematic review protocols on Prospero, aiming to synthesize evidence on COVID-19 treatments on patients of varying severity. So as a group, we saw that there was potentially huge amounts of duplicated or unnecessary work being created. We noted that a lot of the systematic reviews being conducted were actually using the same pool of data, but the difference between the protocols lied in drawing varied subgroups to suit specific research questions. So this motivated us to try and develop a central platform that could hold and synthesize COVID-19 study data, but also allow users to adjust the analysis to suit their research questions. So very briefly, I know we've talked about it already. So network meta-analysis, or NMA, it synthesizes study results involving more than 2 interventions and creates comparisons between all the interventions involved. So the CRSU already hosts a web app to let users carry out their own NMA without the need of specialist software, namely MetaInsight. And this was built using R and the Shiny package. So here is a screenshot of the app. You can navigate through the app using the tabs at the top, including a tab to load in your own data. On the left is a panel to choose further options, from which you can also do a sensitivity analysis by deselecting certain studies, and then you can compare the results to the original analysis as seen here between the 2 network diagrams. So we have a data summary tab, which gives data characteristics, study results, and network plots. We have a tab, which is where you'd go to do your analysis under frequentist methods, and this uses the NetMeta package in R. And finally, we have a tab to do it under Bayesian methods instead. This uses the GMTC package in R, where models are estimated through JAGs. So using MetaInsight as our base, we created a spin-off version named MetaInsight COVID-19. In a nutshell, we developed an interactive web-based platform to allow exploration, various analysis, and interrogation of the up-to-date data from existing living systematic reviews of treatment for COVID-19. So because we wanted our focus to be on developing the app, we didn't carry out the systematic review ourselves. Instead, we extracted systematic review data from the COVID NMA initiative up to the 19th of October, which was the end date of our pilot project. So we stored the data on a Google Sheet, which was then linked to the app via the Google Sheets 4 package. So then each week the data would be extracted and the Google Sheet updated. Having the app linked with the Google Sheet ensured that the analysis results were always automatically updated, which was really useful. And by building on top of MetaInsight, all of the functionality that I described earlier remains in the app. The tab to load in your own data was removed and the summary front page was built instead. So now I'm going to try and quickly take us to the app. So here we have it. At the top, you can see when the data was last updated. Here you can choose which outcome you want to look at. So for the pilot project, we looked at mortality, viral negative conversion, and serious adverse events. You can see the data here. You can see all the many tables of it and the other characteristics of the studies. You can see the network plot down here, and you can choose different styles of network plot. And then here we have a summary of the results in the form of a forest plot. You can also look at different studies if you want to create your own selection. You can choose them literally by clicking, or you can say if you want to only look at those that had critical COVID-19, you can filter that way. And then at the top, using this detailed data analysis, that brings you back to the main MetaInsight app, and it's same functionality, but it's just using this COVID data. So if I go back to the slides. Great. So I just want to quickly go over 2 examples of challenges that we came across during development and how we tackled them. Firstly, quite early on, we found that the size of the network became quite large. This had an impact on the app visually, so network diagrams were becoming cluttered with text overlaying each other, and the forest plots were actually running off the plot space and onto a second plot. Generally, we tackled this case by case by altering the user interface parts of the Shiny code to cope with the size. And secondly, there are a few instances where we found that it would have been beneficial if we could have included node merging and splitting. So the nodes represent the treatments within your network. And so the node merging would involve, say, grouping all of your intravenous treatments in your network as one group, and they would then be analyzed as one group throughout, and then node splitting would do the reverse. So there are a few instances, as seen on this slide here, where we had to decide ourselves whether to group or ungroup the nodes. And whatever decision we made, it obviously remained fixed in the app. Whereas if we had node merging or splitting as a feature, this would allow the user to decide rather than us. So after the process of developing this app, we're now considering, can we develop a living MetaInsight? From what we've learned from the pilot, I think there are 2 options moving forward. The first one is we create something similar to the COVID-19 version, where we create bespoke user interfaces for presenting living systematic reviews of a particular disease area, and then the users explore and interrogate and analyze the data. The second option would be to create a generic user interface similar to MetaInsight, where the users can upload and then update their own living database and then use the functionalities of the app as they wish. Whichever way it goes, I think there are lots of other things that we need to consider before or whilst developing a living MetaInsight, varying from user functionality to intrinsic challenges within the field of living systematic reviews. But overall, the pilot project was successful in that we learned a lot about what would be needed to develop a user interface for living NMAs, and we're keen to develop this further and would love to hear any feedback. So thank you for your time, and I look forward to any questions or discussions.
Thank you so much, Clareece. That's a really excellent example of creating an interactive web-based platform for users to explore. So we're now going to continue with speaker 2, who is Suzanne Freeman. So Suzanne is an NIHR research fellow and member of the NIHR Complex Reviews Support Unit, also based at the University of Leicester. Her research interests include the synthesis of continuous and time to event outcomes and network meta-analysis and diagnostic test accuracy meta-analysis.
Thank you. So hello, I'm Suzanne Freeman, based at the University of Leicester, And today I'm going to talk about MetaDTA and sort of show you some of the functionality available. So MetaDTA is an R-Shiny app that's been developed for conducting meta-analyses of diagnostic test accuracy studies. So in a diagnostic test accuracy study, we're interested in finding out whether the diagnostic test of interest correctly identifies whether patients have a disease or whether they're healthy. And what this means is that the outcomes that we get from these sorts of studies are we get two outcomes, sensitivity and specificity. So sensitivity is the proportion of patients correctly identified as having the disease by the test, and specificity is the proportion of patients correctly identified as being healthy by the test. So what this means is that we have two outcomes which are tend to be highly correlated. So when it comes to fitting a statistical model, we need to fit statistical models that a bivariate model normally, so that we can model both of those outcomes as well as take into account the correlation between those outcomes. So we've developed MetaDTA to try to make it a sort of user-friendly way that allows people who are maybe not sort of statistical experts in terms of being able to sort of write the R code themselves for fitting these models, that they can come to the app, they can load their own data into the app and run their analysis without even needing to install R onto their computer. So today I'm just going to run through the app to show you sort of the main functionality that we've put into it. So this is the homepage for the app, and the key thing here, just to say, if anyone wants to give MetaDTA a go themselves, if you just scroll down, there is this button that says download user guide. So here we've written a user guide which talks about all the different functionalities available and gives you some useful tips in terms of how the format that your data needs to be in as well. So give that a read first. But the app itself is navigated through this top bar. So if we click on to load data, and the idea is that the steps sort of follow the steps of an analysis. So the first thing we need to do is to load the data. So here on the left-hand side, there are the options for loading your data. And on the right-hand side here, we have some of the instructions relating to the format of that data. But what we also have down here, sort of on the bottom of the left-hand side, is there's a number of inbuilt data sets within MetaDTA that allow you can use these to play around with the different functionalities and decide whether this is the application that you want for your analysis, or if you just want to get to grips with some of the different options available. And these can be downloaded, which is very helpful if you then want to put your own data, because you can download the example one and literally sort of copy and paste your data into that, and you'll know it's in the right format. So the next page along is meta-analysis, and this starts with the study level outcomes tab here. So we've got one row per study, we've got a sensitivity and a specificity for each study in our meta-analysis, as well as the weights for both sensitivity and specificity. The next tab along is SROC plot. So the results of a diagnostic test accuracy meta-analysis are commonly displayed as a summary point, which is this blue point in the middle, with confidence and predictive regions in ROC space. So we have sensitivity on the y-axis and 1 minus specificity on the x-axis. Over on the left-hand side, these are the options for customizing the display that you see in your ROC plot. So we can add the summary ROC curve if we wish. I'm just going to take that back off, because the other options we can look at include displaying the disease prevalence from each of the studies. So this just displays as the number underneath the point. Or we can change our data points here. Sorry, I should have said that these are the data points, one for each of the studies in our meta-analysis, to reflect those percentage study weights. So you can see that those small circles have changed now to ellipses, where the vertical distance represents the weight for sensitivity and the horizontal distance represents the weight for specificity. What we can also do is we can add the confidence intervals for sensitivity and specificity for each individual study. And what you can see is that you can build up your plots, but a lot of the options here can be added together. So you can sort of build up and customize your plots as you wish. Just to make life a little bit clearer for this demonstration, I'll just go back to sort of the default option. So MetaDTA supports quality assessment scores that come from the QuadAS2 tool, of which there's 7 domains. So we can look at each domain of QuadAS2 separately by each data point taking a specific colour, green being low risk of bias and red high risk of bias. Or we can also have a look at all 7 domains of risk of bias from QuadAS2 and the applicability concerns in one go by replacing those small data points with mini pie charts. Now, if we click onto the middle of the pie charts, or indeed the data points when they're just little circles, and scroll down to the bottom of the page, we can see an enlarged version of that pie chart, which tells us specifically which domains of the QuadAS2 tool take high or unclear risk of bias in this case. The title can be changed just by typing into the box at the top here, and as you can see, the graph just sort of updates in live format. So I'm just going to remove the risk of bias, because the other option we have is if you have covariates within your data set, you may also want to have a look at those visually. So MetaDTA at the moment doesn't support meta regression, but it does allow you some graphical options for looking at covariates. So the default is just to add the covariate sort of label to the data point, but we can also turn them into coloured points, or we can have both. And down here, all plots within MetaDTA can be downloaded in either PNG or PDF format just by clicking the appropriate option and the button here. And tables can be downloaded in CSV format. The next tab along is statistics. So this gives us the pooled results from our meta-analysis. So this is the pooled estimate of sensitivity and specificity, and also on the logit scale. And then down here on the left-hand side, we have some options to look at some of the other statistics which are commonly reported for diagnostic test accuracy meta-analyses, such as the diagnostic odds ratios and the likelihood ratio. The parameter estimates tab is here. This is mainly if you wanted to include your meta-analysis within a decision modelling framework, then there's some useful statistics here. We have a parameters for RevMan tab. So this allows you to recreate some of the RSE plots in RevMan if you wanted to. So the benefit of doing your analysis in MetaDTA is that it's more statistically rigorous, as it fits the bivariate model, taking into account correlation between sensitivity and specificity. And at the moment, RevMan doesn't. And the final tab is forest plots. So I'm sure we've seen plenty of these today, that we've got a forest plot here for sensitivity and one for specificity as well. The next page along is sensitivity analysis, and this is where I think MetaDTA sort of has one of its major benefits, is that if we wanted to exclude 2 studies which have all domains of QuadAS2 at high or unclear risk of bias, we can exclude those studies just by ticking the name of the study down here on the left-hand side. And then we've got the same tabs as we had on the meta-analysis page, but this time we're just looking at the 11 studies in our sensitivity analysis. And in particular, when we look at the SROC plot, we have this option where we can plot in grey in the background. We can see the original model with all studies, and in the blue in the foreground, we've got the sensitivity analysis. And then the rest of the tabs work very much in the same way as they do on the meta-analysis page. I wish I had more time to talk about some of the other options that are available within MetaDTA, but I just want to finish by saying that this has been built using 22 R packages. So we've really tried to sort of utilise packages that other people have already written to help us build this application to hopefully assist some people with their meta-analyses. So thank you very much.
And that was excellent, Suzanne. And I can personally see a real usefulness beyond just meta-analysis of diagnostic test accuracy. So next, we're going to welcome our final presenter of the day and longtime friend of mine and the ES Hackathon, Kyle Hamilton. So Kyle is a fifth-year health psychology PhD candidate at the University of California, Merced. He's advised by Dr. Linda Cameron and is affiliated with the Health Science Research Institute. His research interests include electronic cigarettes, adverse childhood experiences, health communications, evidence synthesis, and meta-analysis. He's extremely active in the open science community, is a BITS catalyst, and is a community member of the R Open Sci. He has released 5 R packages to date, including Mavis and the meta-analysis module major for Jamovi. So over to you, Kyle.
Thank you very much. So hi, my name is Kyle Hamilton. I'm a fifth-year PhD candidate in the Psychological Sciences program. Really quick about myself. We've already said everything, so I'll just go through it really fast. Shameless plug real quick. I'm graduating with my PhD relatively soon, COVID permitting. So if anyone knows about a postdoc opportunity or anything, I am looking for one. I am really great with R. I love evidence synthesis. I have good teaching evaluations. So feel free to email me at whamilton@UC-Merced. Reach me out on Twitter at Kyle Hamilton, or you can look at my website to find out more about me at kylehamilton.com. One second. There we go. So really quick, what is Jamovi? Jamovi is a free and open source alternative to SPSS. It was first released in 2016. It's used by over 100 undergraduate programs for statistics and psychology. It uses R to perform the background function calculations for any of your statistical tests or methods. Up here is the Jamovi team. These are the guys who actually wrote Jamovi and have been really helpful in getting Major off the ground and helping with my technical problems. So just wanted to give them a shout out and say thanks. Major is mostly based on the R package Metaphor by Wolfgang Bischbauer. It allows for fixed effect, random effect, and mixed effect models. It also allows for reproducible results within both Jamovi and R and is usable as an R package. So when you do your work in Jamovi, you can also then load your data and the Major package into R and reproduce the exact same results, which are the exact same as Metaphor. So it allows for upstream transparency and reproducibility. And really quickly, I just thought this would be nice, pointing out the different packages that are used in Major. Major is a wrapper and a graphical interface. So for the meta-analytic models, most of it is done with Metaphor, including for our univariate and multivariate models. Bayesian models are supported with the Bayes meta package. Publication bias assessment was a large part of the most recent release from a Major, so including Egger's regression, trim and fill, but also the new selection models that we learned about earlier. Same with P-uniform and P-curve. The code comes from either the P-uniform package or the P-curve Shiny app, and Daniel Lincoln's toaster package. So a lot of new features are coming out with more recent additions and changes in this space. Graphics are also mostly supported by Metaphor for your funnel plot, forest plot, etc. And the data handling between Jamovi and the R-Bax engine is handled by the JMV core package by the Jamovi core team. So just thought I'd go through a quick little example. Here we go. Sorry. Okay. So here's an example of how Major works in real time. So we've loaded the Major module in from the Jamovi store. If we go down here to mean differences, we can quickly just load in our data. So for example, it already gives us a quick error saying sample size, mean, standard deviation have to be populated to run the analysis. So for group 1, if I put the sample size, mean, standard deviation for the 2 groups, and then for the source, for study label. Up here comes our analysis. We have our model, which tells us how many studies we had, our estimate for the intercept, our p-value, our confidence intervals, all of our heterogeneity statistics. Also, we learned earlier about the reporter function from a Metaphor, which is also partially implemented into this, giving you a text output of what your results mean. We have our plots, our publication bias assessments, and if we scroll down, we can see we can make lots of changes. For example, we can show like our p-curve output. which will give us a p-curve plot right there. We also can put in any of the other differences to plots. So if we want to make our forest plot larger, that's an option we can do. We just make it slightly bigger. And one of the nice things about this is that if you exporting your results is easy. If you just click on copy and open up something like a Word document, and if you just paste it in, everything goes in. So you're able to make changes to tables to fit whatever standard you need for the journal you're submitting to. Your graphics are all publication grade ready. And if you need to move stuff around, you can get rid of it or change anything you need to. So that was all. Thank you very much.
That's absolutely wonderful, Kyle. So you're really doing important work and just on building capacity in those who want to do robust analyses without necessarily the learning curve of learning, code for new software. And I think that's related to a discussion point then I would like to open up to all presenters. Because we can see that these programs are really important for both novice and occasional users of statistics. But I wonder, is there particular base skills that you would want users to possess before they start using your program? So I'll start with you, Kyle, on that one.
I think that it's important to have a background in statistical theory to kind of really understand what's going on. A perfect example is a funnel plot. A funnel plot doesn't make any sense if you don't understand how normal distribution works, and it becomes kind of point and click. It falls into that that trap of p-values, where people will say, "Oh, this p is greater than 0.05. There's no bias." And when you're thinking about things like bias, which is something I really like thinking about, is bias heterogeneity. If you're thinking about something like heterogeneity and you have high heterogeneity, and you go, "Oh, it's trash, it's no good." Well, if you take it from an intersectional perspective, it's possible you have two very different classes, or if you take something like race and gender into account, those experiences are different in psychology, right? So if you then just throw out your meta-analysis and never publish it because you have high heterogeneity, there might be a really good reason for it, right? And if you don't kind of sit there and think a little bit about it, because it's so overwhelming for some people, then you're missing out on some really important information. Or publication bias. People will say, "Oh, it's trash, can't publish it, has bias." No, that's proof there's bias means something's wrong and it should be published. And I think getting that kind of cultural attitude, but also having that background in statistics is really, really important, because especially in psychology and health, people can get hurt or are still getting hurt if they're not getting these things out. So.
Thank you. That's a really good answer, and something that Neil and I were discussing earlier today, actually. So some people say that all people who do evidence synthesis should know how to code, but to what extent do the presenters then agree? Is there a trade-off between using the user interfaces to make things easier and then trying to get users to really understand what's under the bonnet? So I'll go to you next, Suzanne, if that's okay.
Yeah, that's fine. So I totally agree that I think that to use the MetaDTA app in particular, there does need to be some understanding of the sort of the statistics underneath it. But I don't think you necessarily have to be a statistician to use MetaDTA. And I think the real advantages of these sort of apps is actually for those people who maybe work in the systematic review fields, meta-analysis fields, but aren't trained statisticians. So they have knowledge of the methods, but they don't have the knowledge that allows them to write that code. And so I think that's where these apps come into their own, is increasing the sort of access to doing rigorous statistical methodology, but without needing to sit down and read a handbook on how to code it up in R.
Brilliant. Brilliant, thank you. So you're both agreeing with that there needs to be a balance there then. So move on to you, Clareece. There's a question from Tanya in the chat, and that is, do you have any ideas how to make the platform generic for different diseases? And what do you estimate how much manual effort would be needed to check and adapt the data that's being filled in by users continuously? And would it be less effort to have different interfaces for different diseases? And then finally, for multiple questions, how much effort is it to keep one platform up to date? So you can choose to answer all of that or bits of it. It's up to you.
Yeah, I think it's a really good question. To be honest, it's exactly what we're thinking about at the moment. So a lot of the developing the COVID app was quite particular to the COVID data, and we had the different outcomes. And I think to make it more generic would be difficult because some things were like hard coded, like referring to certain sheets and things that had particular names. So I think it will definitely take some thinking to make it generic, to literally think of any case of data that people might be putting in. So I think it will probably be easier to do the more specific interfaces for each disease area. How much effort is it to keep one platform up to date? I think it was a bit of effort. Again, that's why we decided to have an endpoint on the pilot project, because we were just continuously working on it, and there were just becoming so many questions that were more to do with the actual systematic review itself. And that's when we decided, okay, we've got to have an endpoint for what we've learned here. So yeah, there is a lot of work into it. We're sort of just scratching the surface on this area at the moment.
Thank you, Clareece, for such a comprehensive answer to that question. And thank you to everybody in Slack who are asking questions of our panelists. It makes my job much easier. So Suzanne, we have a great question from Wolfgang in the chat, and he's asked, so he says, first of all, that he might have missed it, but does MetaDTA fit a binomial or logistic bivariate model? Or does it use a normal approximation for the logit sends and logit spec values? Hope I'm pronouncing that correctly.
Yeah, it fits the bivariate binomial model, the one by Chu and Cole. So it doesn't do the normal approximation. So it's using the LME4 package within R really to fit that model.
Thank you so much for your answer. And another question from Wolfgang for you, Kyle. And he's asking about the multi-level part of Jamovi and what kind of models does it cover?
So that was something I started really putting in work into around Christmas. And right now it's just very basic ones that I have directly stolen from your documentation. I'm going to try to make more complicated models so it can be automatically generated over summer break after I get my dissertation done.
I'm sure Wolfgang will appreciate your honesty and the integrity of that. So that's great. So I think we'll move on to a more general discussion then. So are there challenges to maintaining packages when you're producing these user interfaces? And I'll go back to you then, Kyle, for that one.
Yeah, so it's a little challenging. One, people assume I'm an expert, but as I have blatantly shown multiple times, it's all Wolfgang stuff. I just wrote a nice little connector to it. So I get, for example, today I got 3 emails from people asking for meta-analysis help. And it's stuff I'm not an expert in. I just got an email from somebody in Europe asking about confidence intervals in proportions and why their confidence intervals are greater than 1 on one of their proportions estimates. And I'm not trained in that. I'm a psychologist. I'm not really in public health and all that. So it's kind of challenging when people ask for help, especially people in low and middle income countries and areas, because there's already a language barrier and it's hard to tell them I can't help them sometimes. Also, a lot of times I found myself promising I'm going to do something at the next break, like I just did for Wolfgang, and finding out that, oh yeah, I'm a graduate student. I'm busy with my dissertation or, COVID. So.
Thank you, Kyle. I'll go to you, Clareece, if that's okay. Is there any challenges to keeping things updated?
Yeah, well, packages. Do you mean like the packages or the actual app itself? Because like they're slightly different, if that makes sense.
See, I'm showing my ignorance then. So I guess keeping the app updated,
Right.
so that it's usable for everyone.
Yeah, I mean, it's definitely a continuous process. Similar to Carl, like you get people bringing in questions. We have people questioning, oh, does the app do this yet? Does the app do that? And so that just sort of goes onto a list of things to further develop it. And it's very much a continuous process. But I think Suzanne might have more on it because, yeah, I've only been doing this for less than a year at the moment. So I've only had a sneak peek on how it is to keep it up to date.
Yeah, I mean, I would say that because MetaDTA is built on 22 other packages, obviously when the authors of those packages update their packages, that potentially has implications for MetaDTA. I mean, the app has been live for about 2.5 years now, I think. And in that time, actually, the biggest challenge I had was when R updated itself from, I think I was on 3.6 something up to R version 4, and there was 1 or 2 things that changed, and it sort of broke the whole thing initially. I mean, it was on, and that's behind the scenes because obviously the version that's online is using those like versions of the packages that were sort of used for the development. So that was behind the scenes. I was like, all right, how can I change things to make it work again and do exactly what it was doing before. So yeah, there can be challenges.
And we'll go over to Kyle then for a follow-up point on that.
Oh yeah, Suzanne, I just wanted to echo exactly your problem. I run Mavis, which was the precursor to Major, so it's just a meta-analysis Shiny app. And at one point during upgrading it, I absolutely destroyed the server and I had to completely redo it. And I didn't know that a class was using the app for their stuff. And I got like a half dozen emails of these people angry that it broke because I messed up during the upgrading process. So yeah, you all of a sudden become like a Linux administrator as well, magically, when you have host like any kind of Shiny app. And that's just a skill I didn't know I was gonna need.
It sounds like there's a lot of responsibility attached.
I think one thing I learned was that it's definitely good to test it out sort of properly yourself before you make it live to other people. And actually, it's quite handy if you've got a colleague who's maybe not involved in the project, but is happy to sort of sit, have a play and click through the different pages and just check that, it's all working before you make it live.
Yeah, and I think this goes back actually to the beginning session today and the conversation that they had, and Matt Granger was talking about, packages that become extinct and, what can be done with those. And there was just a really rich discussion around that earlier. So it's interesting to see that this applies across all the talks today. So I think unless there's something that anybody else wants to discuss with each other on the panel, otherwise, we'll perhaps wrap up. It's quite late here in Belfast. Brilliant. So thank you so much for joining, everybody. And I really look forward to seeing you all tomorrow, which will be 7 a.m. GMT, my time. And I hope to see you there at Martin Westgate's workshop on writing an R function and developing a package. Thanks.